Hello everyone. I would like to welcome you to the new meetup. Hopefully, after this meetup, you will start your new project in C++. Just 1 or 2 hours ago, I got a message in my company chat that a couple of new things that we are about to write, we should write in Go. Okay, that's fine. It's absolutely a correct choice for the things that we should write, but I would like, after this meetup, to send everyone in my company also Dušan's presentation, and hopefully we will not do it in Go, but we will still do it in C++. Without further ado, I'm giving my words to Dušan. Welcome.
Thank you. So, hi everyone. I'm here to tell you a bit about how to start your C++ project today. A little bit about myself. So, I've been learning C++ since 2006 in school. Started working with C++ professionally since 2012. And since then, I've always worked on some C++ codebase. I've bootstrapped several collaborative projects, one for my own company, one for companies I previously worked for, and I was always somewhat involved in maintaining tooling, libraries, etc. So for tonight, we are going to go to a few things when you should consider when starting a new project. And I'm going to try and give you some kind of rules of thumb on what to do and to help you figure out things when setting up your own project. Because, and who is this for? So this is aimed for everybody, not people who are just starting new project. But because in large corporations, you join the company, you start working on code base, you learn a lot about how to write code, what's good code, but you never get to set up a project from scratch. So I think this is an opportunity for everybody to learn something, and I encourage everybody to try out something like this for themselves. So in C++, there's a lot of complexity. This complexity arrived through time. Right? C++ is a very mature language. And for every step of your project setup journey, you have a lot of choices. There's an abundance of choice, and that might be paralyzing for some people. All right? You have so many choices that in the end, you decided to not do anything. This talk is aimed just for this, to navigate you through whole process and try and give you directions on what's the best choice, or at least what should be the first choice or the default choice when you're setting up a new project. So people say this is not simple, and there's a reason for that. Like C++ is a very diverse language. Bjarne has several talks where he talks about how is C++ used, how wide it is used. Later, you'll get a chance to click on these links, and if you haven't heard these talks, feel free to do so. They're very interesting. Like the creator of language talks about how widespread it is and what are the challenges when trying to maintain a language like this. People use it in very different ways. There are very niche communities. Not every tool is built for every occasion. So it's good to have these specialized tools. So it all comes down to, like the choice comes down to what you're building. And for the purpose of this talk, we're going to really simplify it and say that these are two things, two categories of things that we're going to consider. So you're either building some executable or a library. These are kind of distinct things, and there are tools that cater to one or another. And you're building something internal or external. When I say internal, it's to be used by developers in a team or in a company. And when I say external, you're basically building a product for other people to use. So this product is either closed source and you're shipping it and licensing it, or you're open sourcing it and then other people get to download your library or a program and use it. So these are the things that you should decide on when you pick your tooling. And then there's kind of this asterisk, and that's GUI programs. Like GUI programs are a category of their own. Nowadays, people don't usually build GUI programs in C++. Well, if you need some kind of compute, like heavy processing, you use C++ as a backend. You write a library, and then you inject that library into an application that's built in C# or Node.js, and then you use Electron kind of as a front end. But if you do decide to use the C++ for your application, you're either trying to build a cross-platform GUI, and in that case, you should probably use Qt. It's an open source framework. It's started in 1991, so very old, very mature. It has lots of things already built into it. A lot of it has its own editor. And a lot of the choices there have already been made for you, and this is good. Because in the end, you're trying to build your application or your program. You're not trying to invent a new technology, right? So what you should really be focusing on is delivering features. And it's the same for video games or VR. A lot of people consider Unreal as the default. You might agree, but the royalty model might dissuade you, because after you start earning money, you get to pay back the developers of the engine, but you can use it for free. In that terms, like Godbolt is open source engine. You can use it for free. It's a bit less mature, but still a good starting point for somebody trying to use an open source project to build a game. So in all of these cases, these frameworks are very opinionated. They have their own systems for everything. You don't get to plug in a lot of libraries that you might want to. But in the end, like, this is a good thing. Like, don't try and fight the framework, embrace it, and build the thing that you're trying to build. Okay, so we're not building a GUI program. We're building something else. And first step to set up the project for that is to choose a build system. So what's a build system, and why do we have it? So we're building something, and in the build system world, we're building targets. Targets are either your libraries or your applications. We have build command. The build command is thing you invoke the compiler with. That's called a build command. And in first, it was just that. It was a command line, and you invoke the compiler, and your target gets built. But then you have multiple targets because you have multiple source files. So you write a build script. It can be in any scripting language, and then you invoke the compiler multiple times, and then you invoke linker and whatnot, and that doesn't scale well. So people recognize there are a set of things that you want to be doing, and they built Make. Make was like a new thing in '76. Make is standardized, it's cross-platform, and it's still widely used. So the reason why I put Make almost at the start of this selection process is Make is probably not something you should be using as a default nowadays. A lot of things evolved since '76. Make can do all of the things that need to be done in a build process, but a lot of the things you need to write manually. You don't have out-of-the-box support. And if you want to develop your own build system based on Make, feel free to do so. But if you're really trying to build something, just don't spend your energy there, and use another build system. So to give more context into the whole build system story, we need to look at where does the code live. So the code lives, hopefully, in a repository. If it's not living in a repository in your place of work, it should. There's a lot of version control systems that you can use to make a repository. And the reason why you want your code in a repository is so that you can distribute the source code if you're working in a group, or that you can control the development flow of your development history of your software, go back, go forward, save your progress, iterate, etc. So what gets stored in a repository? So in a repository, we store source and header files. That's obvious, right? That's the thing that we're writing. We also store build system recipes, let's call them, script files, whatever, because we want to build the source code, and that's like a stable thing. It's part of the whole package. Then we store unit tests, or any kind of tests, actually. We store that in the repo as well. Automation scripts, so let's say you have like Docker files or scripts to do some cleanup or any kind of work on the repository. It's good to store them in the repository as well. It's good to share, like every developer automates a process for himself, and then they should give that back to everybody to use and to build this automation code base. So automation scripts definitely belong in the repository. Then we have tool configuration files. So we're gonna mention the tools a bit after in the talk, but it's really essential to store them because everybody then shares the same tool configuration. So let's say your code formatter or linter, static analysis tool, whatever. And then there are things that might belong in a repository, but probably on the iffy side, one of it is editor configuration. People usually don't store that in the repository. You might want to do so if you're a single developer working on a project and this is your favorite thing, and that's how you configure your editor, and you really move machines often, and you want the environment to always be the same. Then there's things like compile commands JSON. I put there because people know that. But any kind of auto-generated files, you should probably not be committing that to a repository. People might do it, but probably not. And then the last thing, you can't even see it because it's totally white. That thing really doesn't belong in a repository. And if you like point the light at you might see what it is, and that thing shouldn't be in the repository at all. Like if you find that, scrub the history somehow. That shouldn't be stored there. Okay, now we know what we're storing, and it's all good. We have a repo, we've set it up for our project, but things can get quite complex. So let's say you have a project, and that's an app, but you're trying to build a library for it. So does this library go with the app itself? And then you have multiple libraries that you reuse across multiple projects. And then maybe this is inside of a company. So what do you do? So there are these two paradigms people use. One is monorepo, the other is multi-repo. So let's see what they represent. So in the middle, you have how the topics and what's happening, right, in each one. So you obviously have multiple targets, right? If you have one target, you put it in one repo, and you don't have this. You have a trivial case of both of these, right? And then for monorepo, everything lives in one repository. For multi-repo, it lives in multiple repositories. And then in the thing that happens as a side effect is that the first-party dependencies, like the libraries and the binaries that pull those libraries as dependencies, treat those dependencies in monorepo as any other target in the repository, and in the multi-repo, they treat it as basically a third-party dependency. Like the same mechanism you would use to pull a third-party dependency, you you use for first-party dependencies as well. And the last thing is the technology used in the repo. So in the multi-repo use case, every repo has its own technology. So you have like the C++ repo for your processing, and then you have the JavaScript repo for the shell, like for the GUI. And in the monorepo, they all live in the same repository. So the technology used to manage a monorepo should be somehow heterogeneous, so be able to interact with multiple technologies. Like the best analogy is the monorepo is like an apartment building, and you all share like the elevator and the heating system and maybe the AC as well. And the multi-repo is like a neighborhood. Everybody lives in its own house. Every house has its own system to do things, but you kind of interact with each other and collaborate on problems. So you really should decide on one of these two because the technologies differ. And it all depends on the use case and what you're trying to build here, right? But know that this is a choice. And in either way, the build system should provide you a set of requirements. Either you're using monorepo or multi-repo. So there are the must-haves, and those are the things Make supported from day one, right? You can define targets, define dependencies between targets, set up build configuration, cache build results, right? And then there are some nice-to-have things, and that's run all my tests. Manage third-party dependencies, generate some code, and do this build in a distributed way. So when I type in build, the jobs get sent to multiple machines because, of course, like a build process takes ages in large projects. So Make can support these, obviously, but not in a nice way. So you can take a look of all the build systems in the C++ ecosystem. There's a lot of them. And you should probably use CMake. It's like, it's a default. If you don't know the reason why not to use CMake, use CMake. If you want other people to build your library from source, use CMake. It's a mature build system. It's built for C++. Developers know how to interact with it. C++-specific tools know how to interact with it. It supports a lot of features that a C++ project needs out of the box, right? So use CMake. Unless you're working in a closed environment where you're in a monorepo, basically. CMake doesn't do, I mean, it can do well in monorepo, but for a large monorepo, probably use something like Bazel. There are other alternatives, but I find this one to be the best. It's mature enough now. It started as a port of Google's internal build system. It's still maintained by people from Google, but it also has its own like open source community. We've set this up in 2018 when we started our own company and haven't regretted it so far. Everything works well, everything is very performant, and it allows us to do things well, like the premium feature there is sandboxing. It allows you to do reproducible builds across development machines, across your build machines, and that experience is very good. Especially when you take into consideration things like multi-language support. So our DevOps team always knows how to interact with any application. It all like the commands are the same, the dev experience is the same. So it's really easy to scale across the company. So yeah, like I said, this is like the build system is the easy choice. CMake for libraries, for open source projects, and C++ only projects, and Bazel if you're working in a monorepo. So yeah, this was easy. And then now we chose our build system, and now we need to set up the developer environment around it. And there are things that we're not going to cover here. One really important thing is the physical ergonomics. We're not going to talk about how to set up your desk. But if you don't know how to do it, you really should. Like, it's a really important thing. Like, research it in your own time, but it should be taught like at your first day of work. And then there are other things that I'm not going to cover, not because they're not important. You know, like choosing an IDE or a terminal theme is a really big process, and a really important thing you need to do. But I don't have a good default. It all comes down to personal preference, like all of them. There's no wrong choice. Maybe there is, but you know, that too is a matter of opinion. So let's look at what's your workflow, like what are you doing? So ideally you're doing this, like you're fetching a main line from your repo, as we discussed. You work on some changes. What is working on changes, you write code, you build, you test, and then you ask for feedback, people give you feedback, and then you apply those changes to the main line. That's the loop. But what actually you're doing, you write some code, right? And then it's ugly, so you format it a bit. You add some new lines to make it more pretty. And then you build your target, but your target builds, and you know that it's building, but sometimes you need to do build all to build all the targets, and then you write tests for your feature, and you iterate on that. But in the end, you really need to run the tests for all the features, or you need to run all the tests so that you make sure that you haven't broken anything. And then you get feedback, right, from other people, and the comments you get is, fix this spelling error, can you break this into a new line, please? This line is too long, and can you use constref for this read-only parameter? And like this is a lot of things that people do, especially when this last give feedback that can take a while. So there are things to speed it up, and they're called continuous integration. Continuous integration gets sold to product people by this line: continuously merge new changes with high confidence. And that's a really good line, but like developers don't care about that. What developers care about removing like things that they need to do, right? So if we automate all of these processes, you get to write your code and then build your code and then test your feature and then get feedback on that. And the feedback should be specific about your feature. And the rest of it gets automated, right? The spelling, the constref thing, we have tools for that. Things have progressed. And all of that is done in CI. So the way it usually works, you build your things, you push it somewhere to a code repository, and that triggers a job on a remote machine that downloads all of your changes and does all of the grayed out things for you and much more. And then it tells you that your change is good or not and gives you feedback. It can also leave you comments on your GitHub, let's say, to fix things if you need that as well. So we should be using CI when setting up a new project. That's the thing. So which CI to use? There's a lot of them. They all do a good job. They're great products. Some of them get bundled with your version control hosting. So you have like GitHub and GitHub Actions, and then you have GitLab and GitLab CI, and Atlassian Bitbucket, and then Bamboo for the CI, and Azure DevOps is a thing where you have your code and the changes. And you have standalone CI tools like Jenkins, TimCity, BuildKite, Circle CI, whatnot. And they all do a great job. And the only important feature there is cost, right? So when setting up your own project, if it's an open source project, you probably get some free build minutes on a cloud server. Which is like somebody else's machine, right? And then ideally, if you're running a C++ project, you really need your own machine. Machines are not that expensive when you consider that you're going to be using it every day. to do all the things that you automated in your code base for many, many years that you're planning to work on your project. So investing just use an old computer that you have at home, use it as a server, let it build stuff. It's much better than doing it locally, right? So this is the keyword is self-hosted runners. So you're still using some of the machines, but you're using the version CI pipeline platforms as like a GUI, but all the job gets executed on your machine. You don't even need to expose it to the internet. It's all webhooks. And the reason why it's easy to self-host it is it's really low maintenance. You just install a package on your machine and it runs. So yeah, set up a CI. And then we come to code formatting. That's another thing that you want to automate. There's this tool, Clang format. It's standard. How to format your code. You have this talk by Kevin Henney. He really tries not to be opinionated, but he basically tells you there's a right and a wrong way to format your code. And he arguments it very well. Let's say in our company, we have a Clang format, and everything gets formatted very strictly, always up to 80-character limit. And the philosophy is, if you want it formatted differently, create a patch for Clang format, and then get it accepted, and then toggle the switch in the config. So people usually just give up, right? It's much better to have consistency in code formatting. It removes a lot of discussions on PRs, and that's really good. But yeah, definitely check out the Kevin Henney talk. So we've set up the formatter now. Yeah. Can you just?
Yeah, thank you. Now, a quick question is if CLang formatter can have some tags that this part of the code shouldn't be formatted.
Yeah.
So ASCII graphic or whatever.
Yeah, you have that.
Oh, yeah.
Yeah, but the way we usually do it is not like we sometimes use the, okay, don't format this piece of code. But the way we usually break it is you have the // comment. And if you put it and at the end of the line, it causes a line break. So you can work around it like that. Our code is full of that. So you have linters and static analysis tools. So this is what I was saying about the use constref for a read-only member. These tools give you messages like that. They get run on the source code, not on the binary. And they find a lot of issues. At some point, they start spitting out some false positives. If your code base is fairly modern, probably not. If your code base is a little bit older, then yes, you have a way to silence them. But those are really good tools. You have commercial ones. You have free ones. If you're on a budget, use the free ones. They're free. You just put it as a job in the CI, and you don't worry about it. Every time you push, it gets executed. The Clang tidy job takes like an hour and a half. You don't care. It's on a remote machine. It gets executed. You can put it to execute once a day. But the feedback is always good. Like when it finds stuff, it really is something that you should pay attention to. You can configure it to turn things on and off. My advice is turn on as much as possible. Turn it all on, and then turn things off that you don't like. Or you are having a hard time to support that type of style of code. So, like even things like you can say, okay, I want to prefix all my private members with M underscore. Like things like that you can put in Clang tidy. And it can enforce that across the entire code base. And there's no way that somebody's going to forget that. So really good. So I've mentioned this file a couple of times, compile commands JSON. It's a file that tells the tools from the previous slide what are your targets and how they get built. It's not only used by those tools, it's also used by IDE tools or things like include what you use. That's a really nice tool that enforces explicit includes for things you are using in your source file or header file, and then removes unused includes. A really good thing, like a really good habit to have. So you want compile commands generated by your build system, ideally. Clang has support for it. Bazel has a plugin for it. You have tools that might do it for you. So you generate this, and then the tools pick it up. And the tools know how to regenerate it. So as you're adding files, they keep invoking the script to generate compile commands. And it's all good. So you need to have that as well. And then there's the C++ core guidelines. Those should be a part of your developer environment. You can enforce these with Clang tidy. Some of them have been codified. Others are just guidelines, but you should use it in your development process. The editors for this project are Bjarne and Herb. Herb is the chairman of ISO C++. Currently, Bjarne is the author of the language, so they know a thing or two. And it's open source. Like you can suggest things, things get discussed thoroughly, and all the guidelines there are for a reason. And things like these push the language forward. So
how much of it is covered by Clang tidy?
Yeah, how many are covered by Clang tidy? You need to turn the mic on if you're going to use it.
How much of the core guidelines are covered by Clang tidy?
Not many, but there are a few. But that's even a few is enough. And the core guidelines really help you with the code reviews part of the workflow. Like if everybody is up to speed on the core guidelines, the code quality gets higher all of a sudden. And if you've read them and people have agreed that this is something that we should adhere to, then some discussions get easier. Can you change this? Why? Oh, this part of the core guideline says so. Oh, okay, cool. And end of discussion, really helps out. And then the last part, I think, of the developer environment is third-party dependencies. You have this talk from CPPCon 2022 that tells the story of the C++ package manager, but it really covers the whole situation of how people manage their third-party dependencies in C++. There's this poll, the questionnaire that gets passed around, and people give answers, and like the talk is very informative. So third-party dependencies are like libraries or tools that you depend on. Let's focus on libraries. And there's like the best description of this, like somebody needs to bring the third-party dependencies, right? Somebody has to do it. So whoever does it, we really don't care as long as they're there and we can use them, right? So the way people do it is they use the build system to fetch the dependencies. Some people use package managers provided by the operating system. Some people use C++ specific package managers. And then some people just paste the code from the library into their own repo. And then it sits there in a third-party folder. And you build that from source. And then you need to figure out how to interface with that build system. And the last way is you build the library locally, and then you as a developer commit all the binaries and the header files to the repo. And the requirements we want from our third-party dependency manager is we want an ability to build things from source, but also do the pre-built binaries thing, and we should be choosing either. We want reproducible builds, so no weird build breaks due to environment changes. We want these cached, and we want to be able to update the third-party dependencies easily, because if updating the third-party dependencies is easy, then it's going to be done frequently. And you really want to be doing this frequently. I had a conversation just before this talk of third-party dependency not being updated for a long, long time, and then it's now the whole project is full with security vulnerabilities. So you really don't want to be doing that, right? So you want an easy way to update all of these so that people get to do it. And this is why I just discard the last two, just on the case of the last one. So I want a tool. And by default, I still believe that build system is the way to go. Package managers, yes, but the build systems enforce the sandbox thing. I might be old. People use package managers successfully. But this is the least effort route for start for big projects. So why I say for start? Because at the start of your project, you're pulling well-known dependencies who have good build systems, especially if you're using CMake and then you interact with another CMake project. That's usually frictionless. And if you pull it through a build system, you can mix and match things. The build from source gets harder to integrate if you're invoking the target build system. There's build flags. There's a lot of things that you need to worry about. And that's the appeal of package managers. And for C++, this is Conan. There's also VC package, but Conan seems to be the way the community is shifting towards. And it's open source, like all the good things that you want to see, fairly mature, but the version 2.0 that fixed a lot of things and changed a lot of things came out in 2023, which is good because they were willing to listen to the community feedback. So all good stuff. It's free. It has the free self-hosted private package server, which is really good if you're running a multi-repo thing. Then you get to package all of your C++ projects into Conan packages and then redistribute them to the other projects in the ecosystem. So yeah, in the end, as I said, more complex. It's physical environment, try not to hurt yourself. For CI, go for the cheapest option, Clang format, use it, Clang ID, include what you use. cspell, I didn't mention that, I just put it here. That's a spell checker you can use to spell check your code. And avoid those. And then for core guidelines, use code reviews and Clang ID. And for third-party dependencies, use your build system or Conan, or force your build system to use Conan, which you can do in Bazel. Like you can tell Bazel, okay, go fetch this Conan package. And I told you that I'm not going to talk about tools, but this one is a special one. It's Compiler Explorer. You should be using this for a lot of different ways. You can use it to build code, to run code, to check assembly, to share some funny code with your coworkers. You can, I know people who you can download your environment in a zip file and then re-upload it. So people upload our internal code base over there and then play around with it in the Compiler Explorer because it's faster to iterate. Things like that. It's a really good tool. It's very mature. It's really a part of the C++ community nowadays. And then its younger sibling is CPP Insights. And it does a really cool thing. I don't know if you can see it, but it's opinionated. It uses the modern C++ code base and kind of transpiles it to a C-like version of it. So it does a transformation on the code to show you like the raw code. And it's really good when you're trying to explore some of the new features that you're not familiar with in the newer C++ standards. You try them out on the left, and then you see how it would be implemented in C, let's say. That's the idea. OK, now we have our project. It's building. We have the third-party dependencies. The code is good. Now we need to package the project and ship it. So how do we do that? There's a lot of ways, and it really, now we're coming back to the internal-external library package thing. So this is the matrix. I won't go through every field. This is my rule of thumb. For internal stuff, you're either using a monorepo, so you don't care about internal packaging, or you're using kind of a container image thing. And for open source, I kind of assume that people can see your source and download it and build it themselves. And sometimes that's enough. But you really want to encourage adoption for your library that you open source. So you might want to go extra mile and include a package manager so people can have an easier time interfacing with it. So one thing people do is amalgamated builds. So for this word, we need a dictionary, and it's to combine or unite to form one organization or structure. OK, so this means like a single header library. That's what I'm trying to say. So amalgamation build is you take all your code and you put it in one header file, or one header file and one C file. People do that because you don't have a whole build system that discovers the source files. You have two files or one. And it's easy. Just copy it or download it and use it, include it. It's suitable only for lightweight libraries. If package adoption happens across the board, we don't need these anymore. But it's probably not going to happen because it's C++ and people like to do things their own way. So if you're a maintainer of a lightweight library, include this so that other people can try out your library, people that are not used to using packages. Otherwise, use the package manager, like I said. You can use Conan for libraries and use open operating system packages for tools. Because people that need to use those tools that you build probably aren't developers, so you want to make things the way they are used to. And that's like a rule of thumb. And then in the end, we have the container images. People know these as Docker images. Docker is a company now. We have Open Container Initiative that is in charge of maintaining the image standard itself. And Docker is a runtime that can run these images, right? And this is good, because it's not owned by a company. It's now a standard kind of thing. And like I mentioned in the table, you use these to package mostly services, not tools, not applications. And there are a few best practices, but to speed things up, if you're interested, we can discuss these. But they're usually like a common knowledge. And none of them are C++ specific. You decided on packaging and everything, and now you need to actually configure all of these tools that you chose. And in C++ world, there's this thing called toolchain, and this means your compiler that builds the thing, your targets. And in C++, the compiler should choose you, not you choosing the compiler. So oftentimes, you need to support a lot of platforms. If you're developing a library, you need to support as many compilers as possible. So you kind of support them all, which is why CI is, again, a big part of it, because you can support multiple compilers by developing on one and have CI set up so that it tracks all of them. And then, like, the version of compiler should be the maximum one that you can use, ideally. But it all depends. You have a balance between how many people do you want to be able to use your library, and then if you're building a binary or an application, just push it all the way. Because of, a lot of good things are introduced in the newer compiler versions. And then there's linker. In other platforms other than Linux, you kind of have the default linker and you use it. In Linux, you have a lot of options. I don't know if these are Windows as well. So there are a lot of options, and you have some kind of guidelines there, but you should probably look at things like link speed, memory footprint, and link time optimizations, and you see what's good for you, and you choose that one. The good thing is that they're really interchangeable, so you don't have to change a lot of your build scripts to switch to a different linker. Just try them out, see what works for you. And if someone requires a specific linker to be used, then it's fine. And then you choose the standard library. Again, standard libraries are part of the compiler toolchains, but on Linux you can use a GCC compiler and link against the Clang standard library and vice versa. In my company, for instance, we use Clang as a compiler because it was faster to implement some of the language features that we wanted, and we use the GCC library because it was faster. For some, it had faster, more optimized implementations for our platform. It's all empirical. We stuck to that. We never investigated, switching. Things change fast there. And on Microsoft and Apple, you have fixed standard libraries that you can use, and you have the CPP reference. Great site. You probably all use it. And there you have this page that C++ compilers support, and there you can find which standard library features are implemented in which standard library. So if you're looking to use a specific feature, or if you're seeing, is it worth upgrading to a newer version, you can use this page. It really helps out to see if it's worth the upgrade. And then we come to toolchain configuration. So you have your compiler, and now it has build flags, and you should configure your build system to pass all of these flags to the compiler. And this is something that you set up once and you forget about it. And here are some of the things I like to set up. So for the standard, go as high as you can, I guess, for applications. This is just how you invoke the line. For errors, like I said, a good thing to do is turn them all on and then turn off with -w, no, the error code, to turn off the ones that you cannot support or cannot build against. And then you configure optimization flags. You turn off RTTI because who uses that, right? And then there's for debug builds, you enable all of these, right? There are sanitizers, unlike static analysis tools. These run in runtime. These flags will generate code, additional code that does a lot of the checks, and it can help with detecting some common bugs. I've just named a few. There are a bunch of them, and a bunch of them popping up because people are really looking to push this C++ security story. So we've configured our toolchain. No recap slide here because it's just a bunch of information. And then in the end, we have the building blocks. Building blocks are your libraries that you pull in, but also other tools. And there are some essentials that you should probably do at the start of your project. Decide whether you need them. The ones on the left, you probably do. So you definitely need some unit testing. So in C++ world, there are a lot of them, but Catch2 and Google tests seem to be the most used ones. There's a Boost one as well, but there's a Boost something for everything, right? So if you're using Boost and you like Boost, go for it. Catch2 has benchmarking support. In Google world, that's a separate project that you pull in for Google benchmarks. And both of them are good. Like for me, Catch2 comes out on top because I like the behavior-driven style of tests. When you describe scenarios and whatnot, you don't describe test cases, but that's a preference. Both of them are built for the C++ community and support most of the features that you might need. Then you need some kind of telemetry, some kind of logging. You have a lot of logs. Something C++ projects don't use very often is OpenTelemetry. It's a new standard. It used to be called Open Tracing, and before that it was Jagger or whatnot. But it evolved really fast, and the C++ community should adopt this. I think I took a look at the project itself. It needs work to get up to standard, but hopefully that comes. And then in the end, you have backward C++. That's a tool which dumps a pretty print of your call stack when your program breaks. You just link it into your binary, and it's nice. It's useful. And then there's a command line interface. You're probably going to need it if you're writing something in C++. We use it a lot for our services, and the library that I put there is really good. It has a really nice interface and a lot of good features. And then on the right, you have standard library extensions. So the first one is Boost. So the way standard works for libraries is they want to see an implementation of a feature somewhere, right? It needs to happen somewhere, and it usually happens in Boost or in these large companies or in small repos. And all of them I call like a standard library extensions. Before ranges got introduced into the standard, there was ranges v3. There's still ranges v3. It has more support. You decide if you want to use that or just the standard one. But a lot of it is in Boost as well. All large companies have their own standard library extension libraries. So you have Abyssal by Google, Folly by Facebook, and BDE by Bloomberg. They contain a lot of things you might need, like containers, like utility classes. It's worthwhile checking them out just to get an inspiration of what you might need or what you might use, or how to write tests. All of those code bases are very well maintained, they're very readable. Just look into it at least, if you're not going to use all of them. But like we all know the story of STD unordered map. And all of these libraries contain a better version of it with the same interface, and just use it and you have a faster map, right? So how to find libraries? There are two ways. Like there's the, every language, you have the awesome something, repo that shows you all the good libraries. And the other way in C++ to find libraries that you can test right away is you go on Godbolt and you get to add libraries, and all of the libraries there are good libraries, and you can try them out. So those are the two ways to discover new libraries and get inspiration to include them in your project. Some of my favorite libraries. On the left, you have the general purpose ones. On the right-hand side, I just put the ones that deal with data serialization. So you have the JSON one by Mr. Lohman. Like that one is really good. It's not the fastest JSON serialization library, but it has a really good interface. So even though it's not the fastest, like you can just read through the code and get an idea of maybe how you should design your interfaces. It has a really good customization system, so you can add JSON support to your types seamlessly. Same for YAML. We use YAML a lot for config files. And there's the simple binary encoding library. It's a binary format. You might know the idea of protobuf and then cabin proto and things like that. And this is the end goal. Like this is basically marshalling the data onto a wire in a structured kind of way. Really fast library used by a lot of financial systems. It was developed by financial community for fintech purposes, so really fast. And on the left, we have the LLFIO by Neil Douglas. A really good library. I like it. It helped us use these OS level APIs, but not interfacing with Linux handles and whatnot. So it's a wrapper around it. There's a path for this library to get into the standard library. But anytime you need a memory mapped file, go look at this library and try and use it. And then there's the format, STD format. So this one did get into the new standard, but I don't know if standard libraries support it at the moment. So we still kind of link against FMT, but it's a really good library, and use it instead of STD cout and IOStream. And then in the end, we have like the CTTI. It's not a maintained library. It hasn't had a change in 6 years, but it doesn't need a change, right? Because the thing this library does is exploit some of the compiler stuff to get you compile time names of symbols. And you use it for compile time reflection, and then you can compile time reflect on something and then store it in a variable, and then you get runtime reflection. It's pretty nice. So with just that one small library, you get reflection. There are other reflection libraries, but like I said, these aren't the best libraries. These are my favorite libraries. And so for the part that probably everybody is looking for is examples, right? So, okay, we did a lot of talk. Now show it how it's done, right? And I considered implementing an example for this, but then I realized other people already did it, right? And they're here in this room, and after this talk, you can go talk to them and not me about how to set up your library. And there's this library, Lock-Free, by Đorđe Nedić. He's over there. And it's a collection of data structures. A really good library. So, like I said, project is an external library. He chose CMake for the build system, as one does. For CI, he used GitHub Actions because the project is hosted on GitHub, and he's leveraging the free build minutes, I think. For packaging, he's just using the build system, so he's not interfacing against the package manager, so he just uses CMake fetch content to fetch third-party dependencies. And for unit tests, he's using Catch2. So, we can go to the library and check it out, right? So, yeah. Okay, so here's the repo. Nice README, right? Always good. And And then you have this part is where the CI lives in GitHub. And as you can see, it's pretty simple, right? For the main branch, he triggers a release build type, and then he just says, okay, check out the repo, run CMake to generate the build files, and then build, and then run tests, right? This is all you need. And then you have another computer there in a data center running this every time you merge code, which is pretty neat. So setting up CI is easy. And then for tests, this is the thing that we mentioned, right? He has a CMake file here, and then he fetches catch2 library like this. So not that hard, right? So version 3.3.2 of catch, and it's just there. And then, another thing that we mentioned is this. So for the tests, he's turning on an address sanitizer. He's using the fno-emit frame pointer for nicer stack traces with sanitizers. And he's also including some other sanitizer checks, right? So you can go and browse through this, but really, really, really nicely set up library. Another one that's not a library, but it's a binary, right? And it's written by Nebojša. Nebojša did a talk in our user group meetup on package managers. So you can go back and listen to that talk if you want to know more about package managers. And his project is a binary that's open source. He uses Nix package manager to manage dependencies. We didn't mention that one, but it's a thing people use. Like, it's a part of the OS package manager group, but unlike Deb or something, Nix is widely used across different distributions to do package dependencies because it supports sandboxing. And like I said, sandboxing is a big thing when it comes to builds and environments. For database, he's using this library to interface, and I think he's using SQLite as a backend, and he's using this as a front end, and then he's using Boost HANA for template metaprogramming, which is a really cool library as well. So we can go and look through his repo a bit. He has the nice badges. I think he didn't set up a CI, but I think it would be easy to do so. And then he's using CMake, and you have all the dependencies that he's pulling, right? So he has an HTTP server, he has static reflection, he has Boost HANA for metaprogramming, he's using the JSON library I mentioned to you before to handle JSON, and he wrote REST server for serving some photos. This was a part of the, I think, university course, so not a product per se, but a really nicely set up project that you can use as a reference if you're trying to set up something similar for you.
It doesn't need a CI, it's a Nix, you just Nix play.
Yeah. So yeah, both of these are frequent visitors of the community. Nebojša is not here at the moment, but you can find him and email him and ask him about his, yeah, sorry.
So I have this question. When you have multiple platforms,
Yeah.
you end up with lots of parameters for different targets. So usually you end up with a shell script of some sort to set this up, or maybe in CI.
Mm-hmm.
So what is your opinion about presets? I haven't seen this one, CMake presets. It's a recent feature to set up this.
No. So I personally don't use CMake, so I haven't seen that one. But sounds great if it exists. Maybe you can come and give a talk about it.
Not about talk just to see if it's applicable in this case, because I'm tired of shell scripts. Setting.
Yeah, so
Settings
in CI, I think people usually use like the CI build matrices. Do you know that?
Yeah.
Yeah. So that's the best I got for doing. In my work, I support one platform. So all of that cross-platform stuff is out of the way for me. But you can reference like all the libraries that we mentioned, like especially the JSON one, like that supports a lot of platforms and compiler versions and everything. So, you know, that's always a good reference. If you are stuck and you don't like the way you do things, you go and look how other people are solving the same problem. And you just need to find the people who have the same problem. So I haven't mentioned them here, but you have really good C++ projects like ScyllaDB. It's a database. You can go maybe look at that one if you're building binaries, or I don't know. For libraries, you have a lot of well-known choices to reference. Yeah.
Azure pipeline is surprisingly good for targets, because obviously they have Windows, but they have Linux, and they have pretty good support of Mac on different like ARM and AMD.
Yeah. Any other questions?
First of all, thank you for the mention. And yeah, just one thing I would like to add also is that all of these tools that were mentioned, one of the really cool ways to use them is pre-commit.
Mm-hmm.
So basically, instead of when you are pushing and then taking a look at the CI to see if something failed, and then you have to wait if it's middle of the day and you know all the offices are using the machines, and then it's not going to take 15 minutes. Then you can basically have each time you basically create a commit, you get stopped if something's not working. Yeah. So that's something that you can do as well.
Yeah, great tip. Any other?
Okay, so there is one online question. And the question is from Miloš. The question is, what do you think in general about using IDE to create, let's say, CMake scripts, or to use IDE to configure toolchains and everything around them, not only in terminal?
I mean, that all depends on what's the culture that, like, who is going to interface with it. Like, if you you have your own IDE and you want it to generate CMake scripts and you're satisfied with that and that works for your workflow, that's I'm fine with that, right? If you're trying to interface with other people, then it all depends. Like, what are you building? Do you use the same editor and whatnot? You know, it depends. But if you're looking to start your own project and you launch Qt or Visual Studio and have it generate the CMake files, that's fine. If that's a way to get you started, for sure.
I do have one question regarding the strategy of dealing with third-party dependencies, specifically
Yep.
if you're building library.
Yep.
Is there any pros and cons when it comes to using package manager versus using build system to pull the dependencies? Like,
yeah, for sure.
We want to make most comfortable for people of any choice. Like,
yeah, so a lot of the C++ libraries, especially the ones I mentioned, don't have a lot of third-party dependencies, because that used to be the C++ way. You have the same thing re-implemented in all of the libraries. There's not a lot of code reuse. So a lot of them don't have any third-party dependency requirements. And I understand that if you're building some more, a specific library for a specific use case, you might want to use third-party dependencies to, not re-implement things. And that's where having a package manager really helps. Like, you really don't want people to discover your third-party dependencies through your build files. It's a hassle. Good thing for now, at least, is that C++ developers are kind of used to that. So every time I go and fetch a third-party dependency, I go through their build system and see what they do. And, it shouldn't be like that, right? But, and if you want a bigger adoption, definitely include a package manager for that. Okay, if that's everything, then go and build stuff.
Thank you, Dušan. Awesome presentation, by the way. I think in my company, this will be the first thing in the morning that I will send. One thing that I wanted to say, thank you all for coming here in such a great number. So I think that's almost 40 people here in the room. So I think maybe this is even the largest meetup that we had so far. So Dušan, very nice. The other thing is, save the date, 12th of April. I won't disclose any details, but we are planning to do something more than regular meetups. So the next one in March will be a regular meetup, but we are planning to do one interesting event in April. So stay here in Belgrade. On the 12th of April, we will have something interesting for you. I think the numbers, we will do that offline. And that is on purpose for the respect of all the people that came here. Thank you. Thank you. And online people, we will save something for them in March. Yes, thank you.